In this video, we're going to continue talking about special right triangles, and this time we're going to focus on 30, 60, 90 triangles. So to get a 30, 60, 90 triangle, what you do is you start with an equilateral triangle, which every angle in that would be 60, but then you cut it in half. So that's going to give you two 30, 60, 90s. Now I have to kind of reference to both of these. So let's imagine that this triangle, we'll go ahead and rotate it around so it looks like the other picture, is one 30, 60, 90 triangle. All right, so looking at our original picture, in a 30, 60, 90, you have, because there are three different angles, there are three different sides. So we're going to call this side the hypotenuse. Across from the 30 side, we're going to call that the short side. And across from the 60 side, we're going to call that the long side. All right, so we have a hypotenuse, a short side, a long side. So across from the 30 is the short, across from the 60 is the long, and the hypotenuse is always across from the 90. Well, remember, since this is a 30, 60, or started as an equilateral triangle, all three sides are the same. So that has to be the same distance as that. So if this is an h, then that whole distance has to also be an h. And there's our first relationship between the sides of the triangle, that the hypotenuse is equal to 2 times the short side. So if you know the short side, and if you double it, you'll get the hypotenuse. Now we're going to go ahead and find a relationship with the long side of the triangle. So now let's take this and do Pythagorean theorem. S squared plus L squared equals h squared. But we just said that h was 2s, so that would give me s squared plus L squared equals 2s squared. Now just squaring on that side, I would have 4, because you square the 2, and then s squared. Now I want to solve for L, so I'm going to subtract an s squared. And that's going to give me L squared equals, well remember, this is 4s squared minus 1s squared, so that would be 3s squared. Then I'll take the square root of both sides and get that L is the square root of 3 times the square root of s squared, which is the square root of 3 times s, or s times the square root of 3. And there's the other relationship that we need. So we have that the leg, or the short leg, or the long leg, I'm sorry, is the short side times the square root of 3. Now I can take those two and manipulate them. Taking this first equation, if you want to solve for s, you would take the hypotenuse and divide by 2. So the short side is always half the hypotenuse. And then I can also do the same thing using this equation. If I solve for s, I would divide both sides by the square root of 3 and get that the s is the long side divided by the square root of 3. Then you would want to get that square root out of the bottom. So notice that all of these formulas revolve around knowing the short side. If they give you the short side, then that's the easiest way to do them. If they don't, the first thing that you find is what the short side would be. So if you know the hypotenuse, you take half of it, you get the short side. If you know the short side, you double it, you get the hypotenuse. If you know the short side, you can multiply by the square root of 3 and you get the long side. And if you know the long side, you can divide by the square root of 3 and get the short side. So let's look at some examples now. So all of these are 30, 60, 90, so I'm just going to go ahead, fill in the right angles at a 30-degree angle. So let's say that we had a problem, like let's take this first one, and say that we knew that the short leg was, let's say, 5. Well, remember, we know that to get the hypotenuse, it's 2 times the short side. So if the short side, and this is really important that you get, the short side is always across from the 30. It's always opposite of the 30. Then to get the long side, or the hypotenuse, we would do 2 times the short side, so that makes that 10. To get the long side, I take the short side times the square root of 3. So if the short side is 5, the long side is 5 times the square root of 3. Let's look at another example. Let's say this time we knew the hypotenuse. So what if the hypotenuse was, let's say, 42? Then to get the short side, you would do half of that, because you double the short side to get the hypotenuse. So then the short side would be 21. And then to get the long side, you take the short side times the square root of 3. So this would be 21 square root of 3. Right? Let's say we know the long side. So let's say I told you, and we'll start with something nice, that this is 8 square root of 3. Well, if you know the long side, to get the short side, you take the long side and divide by the square root of 3. So if I take 8 square root of 3 and divide by square root of 3, that tells me the short side had to be 8. Then to get the hypotenuse, we just double that, and if you double 8, you get 16. Let's look at one more. Let's say that this time I know that the long side is 12. Well, if you know the long side and you want to get to short, you want to divide. So I would take 12 divided by square root of 3, but I can't leave square root of 3 on the bottom. So we're going to multiply by square root of 3 over square root of 3. That gives me 12 square root of 3 over the square root of 9 when I multiply on the bottom, but that's just 3. And then I can simplify 12 over 3 to get 4 square root of 3. Now that's going to be the length of the short side. So this is 4 square root of 3. Then remember that to get the hypotenuse, you just double that. So if I take 4 square root of 3 and double it, I get 8 square root of 3. So that's all there is to it. Now I really just remember 2 formulas, and then I manipulate them if I need to find something else. So to get the hypotenuse, you do 2 times the short side. To get the long leg, or the long side, you take the short side times the square root of 3. And that's really the only 2 formulas on 30, 60, 90s that you have to memorize, because you can always switch those around to find what other variable that you might need.